Om Shri Sai Ram. Previous class we solved many problems based on Ohm's law. Some more problems are given in the textbook. In that first one, look at the question, it is also given in your textbook. The potential difference between the terminals of an electric heater is 60 volt. When it draws a current of 4 ampere from the source, what current will the heater draw if the potential difference is increased to 120 volt? Write the datas whatever given in the question. The potential difference between the terminals of an electric heater. So potential difference is given. What is the how it is denoted? It is denoted by the letter V. So V equal to 60 volt. When it draws a current, how it is denoted? Current is denoted by the letter I. So I equal to 4 ampere. It is also given. From the source, what current will the heater draw if the potential difference is increased to 120 volt? The potential difference in the circuit is 60 volt. It is increased to 120 volt. Then what is the current? How much of current is flow through that circuit? First of all, V is given, I also given. From that, find the resistance of the circuit. It is not given. So find the resistance. What is the formula? V equal to IR. How it is? Because of Ohm's law, V equal to IR is the formula. From this, find R. So R equal to, right? R equal to. It becomes, first write V. Now I is multiplied to R. If it comes to left hand side, it becomes division. So V by I. So what is R? R equal to V by I. Now add the values. What is R? R only. So R. Then V. What is the value of V? It is 60. Then what is the value of I? I is 4. 4 ones are 4, 20. 4 5s are 4 ones are 4, 20. 4 5s are 20. So 4 15s are 60. So this is the resistance. So what is the resistance in the circuit? It is 15 ohm. Now what is the question? The potential difference is increased to 60 volt to 120 volt. So now potential difference is 120 volt. What is the resistance in the circuit? It is same. It is 15 ohm only. Now find the current in the circuit. So what is current? That is I. Use the same formula, V equal to IR from Ohm's law. Find I. So I equals to V by R. I equal to V by R. Now substitute the values. I equal to V. What is V? Now it is 120. Why it is not 60 volt? Because it is increased. The potential difference increased to 60 volt to 120 volt. At that time, what is the current? What is the resistance? Resistance is 15 ohm only. 120. V equal to 120. What is R? R is 15. Now 5 3s are 15. 5 2s are 10. 20 4s are 3 1s are 3 8s are. So I equal to 8 ampere. Now tell me, what current will the heater draw if the potential difference is increased to 120 volt? What current? That is 8 amperes of current will the heater draw if the potential difference is increased to 120 volt. This is the first problem. It is the solution for first problem. Okay, second problem. Resistance of metal wire of length 1 meter is 26 ohm at 20 degree Celsius. 20 degree Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? Now write the datas. Resistance of metal wire of length. What is the length? It is 1 meter. So write L equal to length. It is denoted by the letter L. So L equal to 1 meter. Then resistance of the metal is 26 ohm. So resistance is denoted by R. Write it as 26 ohm. At 20 degrees Celsius, if the diameter of the wire it is denoted by the letter D. So it is 0.3 millimeter. Be careful. Now diameter is given in millimeter. Length is given in meter. What is the SI unit of length and diameter? It is meter. So it is now in millimeter. Convert it into meter. How to convert? We know that 1 meter equal to 100 centimeter. What is 1 meter? It is 100 centimeter. Then 1 centimeter equal to 10 millimeter. 10 millimeter. If we convert 1 meter into 100 centimeter, 1 meter means 100 centimeter, it can be written as 10 to the power 2. What is the meaning of 10 to the power 2? 1 after 2 zeros, that is 100. 10 to the power 2 means 100. How we can write 10 millimeter? 10 to the power 1. 10 to the power 1. Now, we have to convert millimeter to meter. Millimeter to meter. Centimeter to millimeter, 10 to the power 1. So, millimeter to centimeter, it is 10 to the power minus 1. Meter to centimeter, it is 10 to the power 2. The reverse of this, centimeter to meter, it is 10 to the power minus 2. What is the meaning 10 to the power minus 2? It is 0.01. This is 0.1. Now, millimeter to centimeter, 10 to the power minus 1. Centimeter to meter, 10 to the power minus 2. So, millimeter to meter, 10 to the power minus 1 plus 10 to the power minus 2 is 10 to the power minus 3. So, this is 10 to the power minus 3. Or we can write D equal to 0.3 into 10 to the power minus 3 meter. Now, we converted to SI unit, that is meter. So, millimeter to meter, or we can write 3 into 10 to the power minus 4 meter. So, this is D. What to find? If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal? So, resistivity means rho. What is rho? Find the value of rho. We know that the formula rho equal to RA by L. RA by L. This is the formula we already derived. Rho equal to RA by L. For that, R is given, resistance is given, that is 26 ohm. What is A? That is the area of cross section. Is it given? No. So, we have to find the area. So, area equal to area of a wire, because it is given the metal wire of length. So, find the area of that wire, that is pi r squared. What is area? Area equal to pi r squared. A equal to pi. What is r? R means radius. It is given diameter. How to find the radius? This is a circle. This is the center of the circle. If I write AOB, AB is a diameter. Then OB is called radius. AB is diameter, OB is radius. There is any relationship between a radius and a diameter? Yes. The radius, look at this, OB is radius. If the length of AB is 10 centimeter, for example, what is the length of AB? It is 10 centimeter. Then tell me, what is the length of OB? It is always 5. What is the length of OA radius? It is also 5. From that, what we conclude? The radius is always half of the diameter. What is radius? Radius is always half of the diameter. OB is the radius. It is half of the diameter. How we can write? R means D by 2. Why D by 2? Half of the diameter, D into 1 by 2. It becomes D by 2, D by 2 whole square. Or we can write A equal to pi D square by 2 square means it is 4. This is A. Now, this is the value of A. Now, substitute the values. Rho equal to RA by L. This is the formula, required formula. So, rho equal to R. What is R? This is 20. First write R itself. A means pi D square This denominator moves to that denominator. So r pi d squared by L into 4. L into 4. Now substitute the values. So rho equal to R means 26 ohm, it is given, into pi means 3.114 into d squared. What is d? Now it is 3 into 10 to the power minus 4 into 3 into 10 to the power minus 4. Why it is 3 into 10 to the power minus 4 into 3 into 10 to the power minus 4? D squared. D into d. D is multiplied twice, divided by L into 4. What is the value of L? That is 1. 1 into 4. If we substitute 26 into 3.14 into 3 into 3 is 9 into 10 to the power minus 4 into 10 to the power minus 4, 10 to the power minus 8 divided by 4. If we substitute, multiply 26 into 3.14 into 9 divided by 4, we get the value 183.69 into 10 to the power minus 8, or we can write it is nearly equal to 184 into 10 to the power minus 8, or in textbook it is given 1.84 into 10 to the power minus 6. This is the answer. This is the resistivity of that metal wire. Another problem is given. A wire of given material having length L and area of cross section A has a resistance of 4 ohm. What would be the resistance of another wire of the same material having length L by 2 and area of cross section 2 ampere? From this, there are two wires. One wire, its length is L and its area of cross section is A, and resistance also given 4 ohm. So write L equal to, what is the length? Length of the wire is L. L is L only. Then what is the area of that cross section? That is A. It is A only. What is the resistance of that wire? That is R1, because the wire, first wire, its resistance, so R1 equal to 4 ohm. From that we know the formula. R1 equal to rho L by A. Resistance, the formula of resistance is rho L by A. It is equal to 4 ohm. It is 4 ohm. Now can I substitute? Rho means rho, L means L only. What is A? The area also, area of cross section also given, it is A. Equal to 4 ohm. Why? Because R1 is 4 ohm, it is given, so it is equation 1. Now second, what is L in the second wire? What is the length of the second wire? The length of the second wire is L by 2. So L equal to L by 2. What is the cross section of that wire? Cross section A equal to 2A. Find the resistance. What is the resistance of that wire? So write the same formula. R2 equal to rho L by A equal to, we don't know what is the value of that resistance. So R2 equal to rho L. What is L now? It is rho into L by, what is A? It is 2A. Here it is L by 2. So this 2 moves to that denominator. This is 2A into 2. Or R2 equal to rho, write rho as it is. What is L? What is the value of L? It is L only. Or 4A. 2 into 2 is 4. So 4A. Or we can write rho L by A into 4. Into 4. If you substitute, we get like this. Or 1 by 4 into 1 by 4. Rho L by A, then into 1 by 4. What is rho L by A? Rho L by A, from the equation 1, rho L by A equal to 4. So substitute the value, that is 4. Rho L by A. From the first equation we get rho L by A equal to 4 ohm. 4 into 1 by 4. 4 cancelled, so we get 1 ohm. So what is the resistance of the second wire? The resistance of the second wire is 1 ohm. This is the very important formula, very simplest one. This is the method of solving this problem. Next topic is resistance of a system of resistors. What is the meaning resistance of a system of resistors? How resistors, the different resistors means more than one resistors, how they are connected in a circuit. This is the resistance of a system of resistors. There are two types. One is resistors in series and second type is resistors in parallel. First look at the resistors in series. How many resistors are connected in this circuit? R1, R2, R3 means first resistor, second resistor, third resistor. Totally 3 resistors. How they are connected? The resistor 1 end of the resistor 1, it is connected to the another end of resistors 2. Another end of resistor 2, it is connected to end of resistor 3. This connection is called resistors in series. If you look at the diagram, this type of connection is called resistors in series. Why it is called resistors in series? Resistors are joined end to end. If I connect resistors, this is the first resistor, this is the second resistor, and this is the third resistor. If I connect the resistor in this type, is a resistors in series? No, because the resistors are not connected end to end. It is not joined to end. But this is example for resistors in series. Why? 3 resistors are connected end to end. They are joined end to end. So this type of resistance of a system of resistors is called resistors in series. So what is resistors in series? More than one resistors, they joined end to end, means it is a resistors in series. Look at the second type, resistors in parallel. Why they are called resistors in parallel? What is the difference between resistors in series and resistors in parallel? There is any difference between these two? Look at the resistors, this is joined end to end. What about this? Is it joined end to end? No. How they are joined? They are parallel to each other. 3 resistors, R1 resistor, R2 resistor, R3 resistor. How many resistors are present? 3 resistors. How they are joined? They are joined parallel to each other. Look at this, they are parallel. And 3 resistors, they joined at the 2 ends. The 3 resistors, their ends, they are joined at the common end, that is X and Y. This type of connection is called resistors in parallel. This is the difference between resistors in series and resistors in parallel. In parallel resistors, how many resistors are there? 3 resistors or 2 or more resistors, they are connected, they are joined parallel, means this system is called resistors in parallel. Now resistors in series. If resistors are connected in series, what is the total resistance in the circuit? How to calculate the total resistance of the circuit? In this R1, R2, R3, 3 resistors are connected, are joined end to end, and these are called resistors in series. Or this circuit, the resistors are connected, resistors in series. Okay. Now R1, R2, R3, 3 resistors. They are connected end to end. So this is called resistors in series. Now tell me, what is the total current or the electric current in the circuit? If we calculate, the current in the circuit is always same. If we connect ammeter here, we get 5 ampere. Or if we connect ammeter here, what is the current in the circuit? It is also 5 ampere. If we connect here, it is also 5 ampere. So current in the circuit, current is same, current is always same in the circuit. When resistance in series means in that circuit current is always same. Why? What is the reason? Because all resistors are joined end to end. So total resistance is same in the circuit. So I means the current, the flow of electric current is same in the circuit. What about potential difference? Potential difference also same. But if we connect this is V means potential difference, the potential difference of the circuit. If we connect one voltmeter, that is V1, here, another voltmeter here, this is V2, another voltmeter here, this is V3. If we connect 3 voltmeters for every resistor, what do we get? We get the V1 is different, that is V1 plus, then the potential difference of resistor 2 is V2, potential difference of resistor 3 is V3. If we calculate, if we add, if we find the sum of V1, V2, V3, potential difference of V1, V2, V3, it is equal to total potential difference of the circuit. V is different, V1, V2, V3 is different. If we add these, we get total potential difference of the circuit, that is V. Then what is the current? Current is always same in the circuit in resistors in series. Then what is V? V equal to IR. From Ohm's law, we know that. What is V? V equal to IR. Or what is V1? Tell me. IR1. What is V2? V2 equal to IR2. What is V3? It is IR3. I is same in the circuit. If we resistors are connected in series, I is same. So write I. Not, it is not I1, I2, I3 because I is same. R1, R2, R3, it is different because the resistance is different for different resistors. So R1, R2, R3. V1 also different for different resistors. The resistance is different. So potential difference also changing with respect to resistors. Now substitute the values to this. V means, instead of V, write the value of V, that is IR. So IR equal to V1. What is V1? IR1 plus. What is V2? V2 equal to IR2. IR2. Then V3. What is V3? IR3. Now IR equal to, I is common, IR1, IR2, IR3. So I is common. Take the LCM. We get R1 plus R2 plus R3. R equal to, this I goes to right hand side. Now it is multiplication and it becomes division. So I by I. I moves to right hand side. It becomes division. So I divided by I equal to R1 plus R2 plus R3. So R equal to I cancel. So we get R equal to R1 plus R2 plus R3. This is a very important formula. From that, what we conclude? Total resistance in the circuit is total resistance. How many resistors are present? Find the sum of that resistors. For example, it is 1 ohm, this is 2 ohm, this is 3 ohm. Now tell me, what is the total resistance in the circuit when resistors are connected in series? Tell me, what is the resistance? From this we conclude R equal to R1 plus R2 plus R3. How many resistors are present? Add these resistors, then we get the total resistance of the circuit. This is 1 ohm, 2 ohm, 3 ohm. 3 plus 2, 5. 5 plus 1, 6. So total, what is the total resistance of this circuit? That is 6 ohm. Sai Ram.